Number 10. The first asteroid belt crossing. In March 1972, Pioneer 10 became the first spacecraft to enter the asteroid belt between Mars and Jupiter. Mission controllers at NASA's Ames Research Center held their breath as the probe ventured into what they feared might be an impenetrable wall of tumbling rock. What they discovered challenged everything astronomers believed about this region of space. For decades, telescopes had shown the asteroid belt as a dense field of debris, the shattered remnants of a planet that never formed. Scientists calculated that crossing this 200 million mile wide zone would be like navigating a cosmic minefield. The expected collision probability seemed dangerously high. Pioneer 10 was heading into uncharted territory with no way to avoid obstacles, no shields against impact, and no backup plan if something went catastrophically wrong. But as Pioneer 10 entered the belt in July 1972, something unexpected happened. Nothing. The spacecraft encountered mostly empty space. The asteroids that had appeared so densely packed from Earth were actually separated by vast distances, typically over 600,000 miles apart. What looked like a wall of rock from our perspective was revealed as an ocean of void, with occasional islands of stone drifting in the darkness. The discovery fundamentally changed our understanding of the solar system's architecture. Our observations from Earth had been catastrophically misleading, compressed by distance into an illusion of density. The asteroid belt wasn't a barrier at all. It was a highway. Pioneer 10's successful crossing enabled every subsequent mission to the outer planets: Voyager, Galileo, Cassini, New Horizons, all following in the path this brave little probe had proven safe. Pioneer 10's journey through the supposedly impenetrable asteroid belt revealed that space is far emptier than we imagined. But if we were so wrong about a region just beyond Mars, visible through telescopes for centuries, what other cosmic assumptions are we making based on incomplete observations from Earth? Number 9. Jupiter's hidden ring system. On March 4, 1979, Voyager 1's cameras captured something that no astronomer had predicted. Mission scientist Linda Morabito was analyzing navigation images when she noticed a strange arc of light extending from Jupiter's edge. The planet that Galileo had first observed in 1610, studied by generations of astronomers through increasingly powerful telescopes, had a ring system that had remained completely invisible from Earth. For over 300 years, Jupiter had been scrutinized by humanity's best instruments. Saturn's magnificent rings had been known since 1610. Yet Jupiter, supposedly well understood and thoroughly mapped, had kept this secret hidden. No telescope on Earth had detected even a hint of these rings. Every astronomer who had ever pointed an instrument at Jupiter had looked directly at this feature and seen nothing. What makes Jupiter's rings so eerie is their near invisibility. The main ring extends approximately 140,000 miles from the planet but measures only about 20 miles thick. Composed of dust particles kicked up from the tiny moons Metis and Adrastea, the rings reflect barely 5% of the light that strikes them. They're constructed from material darker than coal, absorbing light rather than reflecting it, cosmic shadows rather than bright bands. Voyager 1 discovered them almost by accident. The camera happened to be positioned perfectly to catch sunlight, scattering off the dust particles at just the right angle. Voyager 2 confirmed their existence 4 months later. Since then, the Galileo orbiter and Hubble Space Telescope have observed them, but only with great difficulty. From Earth, even with our most advanced technology, Jupiter's rings remain almost impossible to detect. Jupiter's rings remind us that even the most studied objects in our solar system can hide enormous features in plain sight. The discovery came not from better technology, but from a better vantage point, a perspective only achievable by leaving Earth behind and seeing familiar worlds from unfamiliar angles. Number 8. Uranus's extreme axial tilt. On January 24, 1986, Voyager 2 became the first and only spacecraft to visit Uranus. As it approached, scientists confirmed what telescope observations had suggested, but never fully explained. Uranus is tilted 98 degrees on its axis, essentially rolling through space on its side like a cosmic bowling ball. But Voyager 2 discovered the tilt's consequences were far stranger than anyone predicted. Most planets spin like tops, their axes roughly perpendicular to their orbital planes. Earth tilts 23 degrees, giving us seasons. Even extreme examples like Mars or Saturn maintain recognizable orientations. Uranus breaks every rule. One pole faces the sun for 42 Earth years of continuous daylight, while the other endures 4 decades of darkness. Then they swap. Generations pass an endless day, followed by generations in endless night. Voyager 2's measurements revealed even more disturbing anomalies. The planet's magnetic field is tilted 59 degrees from its rotational axis, the most skewed alignment in the solar system. Even more bizarre, the magnetic field's center is offset from the planet's center by 1/3 of its radius, as if something had violently displaced Uranus's magnetic dynamo. The planet's 27 moons orbit in the same tilted equatorial plane, suggesting they formed after whatever river catastrophe knocked Uranus onto its side. The leading theory proposes a collision with an Earth-sized object during the solar system's violent youth, but the mathematics don't work. Such a massive impact should have scattered Uranus's moons, not left them orbiting in perfect alignment with the new tilt. Something catastrophic happened to this planet that our current models of planetary formation cannot adequately explain. The collision theory creates as many mysteries as it solves. Voyager 2's encounter with Uranus revealed a world where summer and winter aren't measured in months, but in generations, where the magnetic poles wander far from the geographic poles, and where every 42 years, the entire hemisphere that has known only darkness finally sees the sun. Something rewrote the rules of planetary physics at Uranus, and we still don't know what. Number 7. Triton's retrograde orbit and nitrogen geysers. On August 25th, 1989, Voyager 2 completed its grand tour of the outer planets with a flyby of Neptune's largest moon, Triton. Scientists expected a frozen, geologically dead world in the outer reaches of the solar system, a chunk of ancient ice that had remained unchanged for billions of years. Instead, Voyager 2 discovered the coldest known planetary surface with active geology, nitrogen geysers erupting through the ice at negative 391 degrees Fahrenheit. At that temperature, nitrogen should be frozen solid, locked in ice harder than granite. Chemical reactions effectively cease. Geological activity requires heat, and heat dissipates rapidly in small bodies. Triton should be as dead as a moon can be, a fossil from the solar system's formation, its interior long since frozen solid. Yet Voyager 2's cameras captured several active geysers erupting from the surface, shooting plumes of nitrogen gas and dark organic compounds up to 5 miles high before they drifted eastward in Triton's thin atmosphere. The moon's surface tells a story of recent geological violence. Relatively few impact craters suggest the surface has been renewed within the past 100 million years. Of cryovolcanism, where water mixed with ammonia erupted like lava, freezing as it flowed. What makes Triton even more mysterious is its orbit. It circles Neptune backward, the only large moon in the solar system with a retrograde orbit. Moons don't form this way. Triton must be a captured object, likely a Kuiper Belt dwarf planet that wandered too close to Neptune billions of years ago. But the capture mechanism required to achieve its current stable, circular orbit remains unexplained. The tidal forces from such a capture should have generated enormous heat, but that was billions of years ago. Voyager 2 revealed that even in the coldest, darkest reaches of our solar system, geological activity persists against all expectations. What drives these eruptions on a moon that should be completely frozen remains one of planetary science's enduring puzzles, a reminder that our assumptions about dead worlds have been proven wrong time and again. Number 6. Pluto's geological complexity. On July 14th, 2015, after a journey lasting 9.5 years, New Horizons completed its 3 billion-mile voyage to become the first spacecraft to visit Pluto. Scientists expected a crater-pocked ice ball, a frozen relic unchanged since the solar system's formation 4.5 billion years ago. Instead, the probe's cameras revealed something that shouldn't exist, a geologically active world with a massive heart-shaped region of smooth, crater-free ice that couldn't be more than 100 million years old. Pluto is tiny, smaller than Earth's moon. Small bodies lose their internal heat quickly, becoming geologically dead within a few 100 million years of formation. Pluto should have frozen solid eons ago, its surface a preserved record of ancient impacts. Yet New Horizons discovered a surface that tells a completely different story. The left side of the heart-shaped region, called Sputnik Planitia, shows not a single impact crater across its 1,000-mile width. The smooth plains aren't just young, they're active. Nitrogen glaciers flow across the surface. Mountains of water ice rise 11,000 feet high, floating on a denser substrate of nitrogen ice like icebergs. The surface is divided into polygon-shaped cells about 20 miles across, created by convection currents in the nitrogen ice layer. These cells form, break apart, and reform in a continuous cycle, constantly erasing any craters that might form. New Horizons also detected a thin atmosphere extending 1,000 miles high, and found strong evidence for a subsurface ocean of liquid water. But here's the mystery. What generates the heat? Pluto lacks significant tidal heating, like Jupiter's moons. Radioactive decay in its core should have stopped producing meaningful heat billions of years ago. Some unknown process is keeping Pluto's interior warm enough to drive surface geology and maintain a liquid ocean beneath miles of ice. At the edge of our solar system, on a dwarf planet that should be completely frozen, something continues to reshape the surface, and we don't know what. The smooth plains of Sputnik Planitia are younger than the dinosaurs, but renewed by processes that defy our understanding of how small, distant worlds should behave. Number 5. Neptune's supersonic winds. On August 25th, 1989, as Voyager 2 made its closest approach to Neptune, the spacecraft's instruments detected something that that violated every model of planetary atmospheres. On this frozen world, over 2.8 billion miles from the sun, winds were screaming across the cloud tops at 1,200 miles per hour, the fastest ever measured in our solar system, on the planet that receives the least solar energy. Every atmospheric model predicts that wind speed should correlate with solar heating. More energy from the sun creates more atmospheric convection, driving stronger winds. Earth, at 1 astronomical unit from the sun, experiences hurricane winds that rarely exceed 200 miles per hour. Jupiter, 5 times farther from the sun, has winds around 400 miles per hour. The pattern should continue. Less solar energy means calmer atmospheres. Neptune destroys this assumption. It receives less than 1/900th of the solar energy that reaches Earth. Its cloud top temperature hovers around negative 353 degrees Fahrenheit. By all logic, Neptune's atmosphere should be relatively calm, its methane clouds drifting slowly in the dim sunlight. Instead, Voyager 2 measured wind speeds exceeding those of any other planet, including gas giants far closer to the sun. The mystery deepens with measurements of Neptune's energy budget. The planet radiates 2.6 times more energy into space than it receives from the sun. Some internal heat source is pumping enormous amounts of energy into Neptune's atmosphere, driving these supersonic winds. But what? Neptune formed 4.5 billion years ago. Any heat from its formation should have radiated away long ago. Radioactive decay in the core can't account for the energy output. Something is generating heat inside Neptune that our models can't explain. Voyager 2 also observed a massive storm system called the Great Dark Spot, roughly the size of Earth. When Hubble observed Neptune just 5 years later, the spot had vanished entirely, replaced by a different storm system in another hemisphere. Neptune's atmosphere churns and evolves on timescales that seem impossibly fast for a world so starved of solar energy. On the coldest, darkest edge of the planetary solar system, winds race at supersonic speeds, powered by an internal furnace we cannot explain. Neptune's atmosphere shouldn't be this violent, this active, this energetic, yet with every rotation, it defies our understanding of how planetary atmospheres should behave. Number 4. Io's volcanic apocalypse. On March 5th, 1979, 3 days after Voyager 1's closest approach to Jupiter, navigation engineer Linda Morabito was examining images of Jupiter's moon Io to determine the spacecraft's precise position. She noticed something bizarre in a long exposure image, an umbrella-shaped cloud extending 190 miles above Io's surface. It was a volcanic eruption, the first ever observed beyond Earth. The discovery meant everything scientists thought about small moons was catastrophically wrong. Small moons don't have volcanoes. They cool quickly, their internal heat radiating into space within a few 100 million years. Io is only slightly larger than Earth's moon, which became geologically dead over 3 billion years ago. Scientists expected Io to be a frozen, cratered wasteland. Instead, Voyager 1 discovered 8 active volcanoes erupting simultaneously. When Voyager 2 flew past 4 months later, it found 9 active eruptions, 1 new volcano and 1 that had gone dormant. The scale of Io's volcanism defies comprehension. Over 400 active volcanoes have been identified since Voyager's discovery. The lava temperatures reach 2,960 degrees Fahrenheit, hotter than any current volcanism on Earth, approaching temperatures only seen in Earth's ancient past. Io completely resurfaces itself approximately every 1 million years, constantly burying its own craters under fresh lava flows. No impact craters exist on Io's surface. They're erased as quickly as they form. The source of this extraordinary heat is tidal flexing. Jupiter's immense gravity stretches and compresses Io as it orbits, generating friction inside the moon. But the mathematics are disturbing. Some planetary scientists believe Io's interior might be almost completely molten, more similar to a planetary embryo still in formation than a moon. The tidal heating is so intense that Io may have a global magma ocean just beneath its crust, making it the most volcanically active body in the solar system by an enormous margin. Voyager 1's discovery revealed that our solar system's most violent geological activity occurs not on planets, but on a moon constantly torn apart by gravitational forces. Every 42 hours, Jupiter's gravity flexes Io enough to keep hundreds of volcanoes continuously erupting in an endless cycle of destruction and renewal that will continue until Jupiter itself dies. Number 3. Evidence of Europa's subsurface ocean. When Voyager 1 photographed Europa on March 5th, 1979, it revealed a surface unlike anything seen before, a smooth ball of ice covered in dark linear features that looked disturbingly like cracks in a frozen shell. Voyager 2 confirmed these weren't impact craters, but fractures extending thousands of miles across the surface. Scientists proposed something radical. Beneath Europa's icy crust might lie an ocean of liquid water, making this distant moon one of the most likely places in our solar system to harbor life. Europa's surface is extraordinarily young. Crater counting suggests it's only 20 to 180 million years old. Practically practically newborn in geological terms. Something continuously renews the surface, erasing impact craters almost as quickly as they form. The linear cracks, called lineae, appear to be places where the ice shell has fractured and separated, with new ice welling up from below to fill the gaps. Some fractures show evidence of ice flows and resurface patterns similar to Earth's polar regions. What makes Europa truly remarkable are the implications of that subsurface ocean. Scientists estimate the ice shell is 10 to 15 miles thick. Beneath it may lie an ocean 40 to 100 miles deep, potentially containing 2 to 3 times more water than all of Earth's oceans combined. Later missions, particularly the Galileo orbiter from 1995 to 2003, detected a magnetic field entirely consistent with a salty, electrically conductive ocean. The evidence has become overwhelming. Europa has a global ocean, but the profound mystery isn't whether the ocean exists. It almost certainly does. The mystery is what that ocean might contain. Unlike Earth's surface oceans, Europa's ocean would be in direct contact with the moon's rocky mantle. Mineral-rich water, geological activity, and liquid water, the 3 key ingredients scientists believe are necessary for life. The tidal heating from Jupiter that keeps the ocean liquid also creates temperature gradients and chemical energy that could power biological processes. Voyager's images of Europa transformed the search for extraterrestrial life. For decades, we looked to Mars, studying ancient dry riverbeds and searching for traces of long-dead microbes. Europa offers something far more immediate, an ocean existing right now, kept liquid by the same tidal forces that power Io's volcanoes. If life arose in those dark waters, isolated from sunlight for billions of years, it would prove that biology doesn't require the sun, only liquid water, chemical nutrients, and time. Number 2, the pale blue dot. On February 14, 1990, at a distance of 3.7 billion miles from Earth, Voyager 1 turned its camera backward for a final look at the solar system it had explored. At the request of astronomer Carl Sagan, engineers commanded the spacecraft to capture a family portrait of the planets. The maneuver required rotating the spacecraft in ways that risked damaging systems critical to the mission. NASA nearly refused, but Sagan persisted, arguing that humanity needed to see what Earth looked like from the edge of the solar system. In one image from that 60-image sequence, Earth appeared as a pale blue dot suspended in a beam of scattered sunlight, occupying just 12/100ths of a single pixel. It was the farthest image of Earth ever taken, captured from a distance so vast that light from the sun took 5.5 hours to reach Voyager 1's position. At that distance, with that perspective, Earth revealed its true nature, a mote of dust suspended in cosmic void. The image contains no scientific data that couldn't be obtained elsewhere. No measurements, no discoveries, no new facts about planetary science. Yet it became one of the most profound photographs ever captured. That pale blue pixel contains every human being who ever lived. Every war, every peace treaty, every scientific breakthrough, every work of art, Cleopatra and Einstein, the construction of the pyramids and the first moon landing, all of human history compressed into a fraction of a pixel, barely visible against the empty darkness. Carl Sagan later wrote about that image with words that captured its significance. That's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. From Voyager 1's perspective, national borders vanish, ideological conflicts seem absurd, and the fragility of our only home becomes undeniable. The photograph provides no new astronomical knowledge, but it fundamentally changed how humanity sees itself in the cosmos. After capturing this image, Voyager 1's cameras were shut down permanently to conserve power, making the pale blue dot among the last photographs the spacecraft would ever take. Number 1, the boundary of our solar system and the interstellar medium. On August 25, 2012, at a distance of 11.7 billion miles from Earth, Voyager 1's instruments detected a sudden, profound change. The solar wind, a supersonic stream of charged particles flowing outward from the sun at 1 million miles per hour, vanished within days. Simultaneously, cosmic rays from interstellar space increased dramatically. After traveling farther than any human-made object in history, Voyager 1 had pierced the heliosphere and entered the space between the stars. It had crossed the boundary where our sun's influence ends and the galaxy begins. The heliosphere is the bubble of solar wind that surrounds our entire solar system, protecting us from the full intensity of galactic cosmic rays. Scientists knew it had to have a boundary somewhere, but they didn't know where or what that boundary would look like. Theoretical models suggested a relatively smooth smooth spherical edge located perhaps 8 to 10 billion miles from the Sun. Voyager 1 crossed it at 11.7 billion miles. 6 years later, Voyager 2 crossed the heliosphere at a completely different distance and angle, revealing that the boundary isn't spherical at all. It's irregularly shaped, fluctuating with the solar cycle, constantly expanding and contracting like a breathing organism. Even more unsettling are the measurements Voyager 1 has transmitted from interstellar space. The interstellar medium, the baseline material of our galaxy, the primordial soup from which stars and planets form, doesn't match our predictions. The density is higher than expected. The magnetic field orientation is different. The energy spectrum of cosmic rays shows features no model anticipated. Every measurement reveals how wrong our theories were about the most fundamental environment in the galaxy. What makes this discovery truly profound is what it means for the Voyager's continuing mission. These spacecraft are now exploring an environment no human-made instrument has ever sampled. They're measuring the actual real properties of interstellar space, replacing our theories with data transmitted across 5.5 light hours of emptiness. The instruments are powered by decaying plutonium generators that lose power every year. Scientists estimate that by 2025, they'll have to start shutting down systems. By 2030, Voyager 1 will likely fall silent. But silence doesn't mean the end. When Voyager 1's transmitter finally lacks the power to reach Earth, the spacecraft will continue drifting through the interstellar medium at 38,000 miles per hour. In 40,000 years, it will pass within 1.6 light years of the star Gliese 445. By then, humanity will either have spread throughout the galaxy or cease to exist entirely. But Voyager 1 will remain, still carrying the golden record, a time capsule of Earth containing sounds, images, and music, selected to represent human civilization to any intelligence that might eventually find it. Voyager 1's crossing into interstellar space represents humanity's first physical presence beyond our sun's domain. Every signal it transmits, traveling at the speed of light for over 22 hours to reach us, contains measurements of an environment we've theorized about but never touched. When its power fails in the coming years, Voyager 1 will become our first permanent artifact in the cosmic ocean, a 500-pound spacecraft from a species that once looked up at the stars and wondered what lay beyond the edge of their world, now adrift forever among those very stars, carrying humanity's first message to the universe into an endless night that has only just begun. If you want to see more videos like this, click the video on screen now and make sure to subscribe.